Hello, my lovely viewers. Welcome again to Mathematics and I. It is your favorite presenter, Jeff Nino. And today we will begin the topic circle geometry. Okay, circle geometry. And of course, for you to understand circle geometry proper, you need to know the theorems that governs it. Okay, so in each of our videos from today, we will be discussing each theorem in a video. Okay, so that for example, the video today talks about theorem 1. All right, the video today talks about theorem 1, which has to do with perpendicular chord bisector. Perpendicular chord bisector. And not just discussing the theorem, but we are also going to be solving examples. So after you know the theorem, what is the next thing you need to learn? How do you apply the theorem in solving problems? If this is your first time joining us, you are welcome to our channel. But please don't forget to subscribe. Don't forget to put on your notification button so you always get notified when we give our videos. Okay, let us proceed with the class. If we have a circle and we have a chord is a line that divides a circle into segments. It is a line that divides a circle into segments. Or you can say it is a line that divides the circle into two unequal parts. Okay, it is not diameter. Diameter actually divides the circle into two equal parts. Now, if this is a chord, okay, and we assume here to be the center of the circle, if I should draw a line from the center to this point, it is actually referred to a radius, because a radius is a line that is drawn from the center of a circle to any point on the circumference. Now, if I should draw again another line to this point, it is also known as a radius, because I also draw from the center of the circle. Okay, now if I should say this is point O, and here is A, and here is B. All right. Now, for what you can see now, AOB is an isosceles triangle. Now, most of us don't know what an isosceles triangle means. Now, an isosceles triangle are triangles that has two sides equal. Two sides are equal. All right. Now, the question is, which are the two sides that are equal in triangle AOB? The two sides are the radius. Why? Because both lines were drawn from the center. So if I should draw a line from the center to this point, and from that same center I draw this line, it means both lines are equal. So because this line AO and line BO are equal, and this line is a chord, this is an isosceles triangle. So now, how do we bring theorem 1 out of this diagram we have on the board? Now, if I should draw a line, okay, if I should draw a line from center O to the point in the chord, which is line AB, this line is perpendicular to line AB. And when a line is perpendicular to line AB, what has it done? It has bisected line AB into two equal lengths. It means if here is O, let's say here is C. Now, normally or naturally, the total length of the chord is AB. But after we have introduced the line which bisected the total length of the chord AB, it means we now have two lengths, AC and BC. But don't forget, AC is equal to BC because the line divides the length into two equal parts. And also, angle 90 are formed. Angle 90 and angle 90, such that angle 90 plus angle 90 will give us sum of angles on a straight line, which is 180 degrees. So this is how your perpendicular chord bisector theorem looks like. All right. Now that we know how the theorem looks like, the next is how do we use this theorem in solving problems? Now, in today's class, I will be giving two examples. And with these two examples, you can use and apply in solving other problems at home. Okay, so now let us begin with the example proper. All right. Okay, let's erase this. Okay. Okay, now example number 1. Please make sure you pay attention so you understand what I am doing. Now, example number 1 says a chord of a circle radius √3 centimeter. So it means in this question our radius is √3 centimeter. √3 centimeter. Okay, subtends an angle of 60 degrees, meaning our theta is 60 degrees at the center. Okay, now find the length of the chord. Now the length of the chord here is question mark. We don't know. The length of the chord is a question mark. We don't know. Now, how do we go about solving this problem? All right. Now, of course, the options given in the questions were option A, √3/2. Option B was 3/2. And option C was 3. And option D was √3. Okay. Now, let us solve this problem. First of all, let us apply the theorem 1 in solving this problem. Okay, this is a circle. Please don't mind this. It's a freehand drawing. And this is the chord. You must draw your chord. This is the chord. And let's assume this is the center of the circle. All right. And then we were told that the radius was given. The radius was given. Now, from here to this place is the radius. And here also is another radius. So we were told that the radius is √3. And if here, let's say here is A, O, B, to make more sense. Now, if line AO is √3, which is the radius, don't forget that BO is also a radius. Because these both lines are equal to each other according to the explanation we made from the beginning. They are isosceles triangle. So here is also √3. And then now we are told that the angle at the center was 60 degrees. Please don't forget that. All right. Now, without wasting time, we are now told to find the length, which is line AB, the total length. Now, let us introduce our bisector. If we introduce this line, okay, and call this C, line OC, you will notice that I bisected the length into two, AC and BC, and not just the length alone, I also bisected the angle at the center. So it means from this part here will be 30, and from here also will be 30. Okay, so if I should draw another diagram so it makes more sense, we're going to have it something like this. Sorry. Okay, center, radius, the bisector, A, O, B, C. Now here becomes 30 degrees, and here becomes 30 degrees. Because why? I bisected. And now, here C remains √3, and also here C remains √3. Now, don't forget that this is angle 90. Don't forget this is also angle 90. So we also have it here, angle 90 and angle 90. Now, the question for us to solve here is to find the length of the chord. Now, do you know that if I am able to get AC, I have also got a CB because we said line AC is equal to line BC. So now how do I solve for line AC or how do I solve for line BC? Now look at what I'm going to do. In triangle AOC, let's bring it out. A O C. Now here is 90 degrees, here is 30 degrees, and here is root 3. Now I am looking for AC, one part of the length. So let's here be X. Now the question is, if I'm looking for X, it means we are going to apply trigonometry. Don't forget the basic angles, or sorry, the what's it called? We have in trigonometry so, ka, twa, which are referred to as the basic trigonometry ratios. And we know that so represents opposite over sine theta is equal to opposite over hypotenuse. Ka means cos theta is equal to adjacent over hypotenuse. And twa means tan theta is equal to opposite over adjacent. Now the question you would ask yourself is, let's come back to triangle AOC. Now, this is the hypotenuse, H. This is the opposite, O, because it is the side facing the angle given. And this is the adjacent. Now, between the hypotenuse, the opposite, and the adjacent, you will notice that it is adjacent that has nothing on it. In hypotenuse, we have root 3. In opposite, we have X. But in adjacent, we have nothing. So you will not come back to the basic trigonometry ratios, which are so, ka, twa. You will check between so, ka, and twa, which one does not carry adjacent? Because in the diagram, adjacent carries nothing. So you will see that it is so. Because while in ka, there is adjacent. In twa, there is adjacent. So what am I going to use? I will be using so in solving the problem. Alright, so I'll come here. S means sine theta is equal to O means opposite over hypotenuse. Now, don't forget, theta here we are using now is 30 degrees. That is the angle here. We are not using this angle, no, we are using 30. So here becomes sine 30 is equal to opposite. Now, what did I say is the opposite now? Opposite is O, which is X. X over hypotenuse is root 3. Now, sine 30 degrees is simply 1 over 2 or 0.5. But let's make use of 1 over 2 to avoid decimal points. Okay. Now, so sine 30 now becomes 1 over 2 is equal to X over root 3. And of course, what do? Cross multiply. Now, 2 multiplied by X gives us 2X. And 1 multiplied by root 3 gives us root 3. Of course, we are looking for the value of X. And for us to get the value of X, it means X has to be the subject of the formula. And for X to be the subject of the formula, we have to divide both sides by 2. So here becomes over 2, and here becomes over 2. So of course, when 2 cancel out 2X is equal to root 3 over 2. But please, don't forget, this is not our final answer because X is here, AC, just here. But we were told to find the total length, AB. So I told you, if here is root 3 over 2, which is X, it means here is also root 3 over 2. Alright, so I will just say therefore, AB, line AB becomes 2 times root 3 over 2. Now the question is, how did I get 2? Because I have 2 sides here. How did I get root 3 over 2? The value of one of the side AC. So class, if 2 should cancel out 2, what do I have left? It means length AB now becomes root 3 centimeter, which of course is option D. Now you see, in some cases, some students will stop here because if they should see the options, they have gotten an answer that is in the option. But that is not where you should stop. You were not told to look for a part of the length of the chord. No, we were told to look for the total length of the chord. Now this is the answer we get after applying perpendicular chord bisector, which is theorem 1. But I can actually teach you again another method for solving this same question, but not using the diagrams above. I hope you want to know that. I know. So let's go about it. This same question, but with a different pattern. We don't need diagrams, we don't need that perpendicular bisector, we need nothing. Only what we need is a formula. Just a formula, and we are good to go. Right, let's do that. Now, we are told to find the length of a chord. Now, the length of a chord has a formula. And what is the formula? 2r sine theta over 2. Now, mind you, the division sign is not affecting sine or 2r, it's only affecting theta. So, with this formula, let us see what we would do if we are still going to get the same answer that we got. Now, length becomes, don't forget radius is root 3. So here becomes 2 multiplied by root 3 multiplied by sine. Now theta was given as 60 degree. 60 degree divided by 2. And of course, here becomes length is equal to 2 times root 3 times sine 30 degrees. Now the question is, how did I get 30? 60 divided by 2 gives us 30. And of course, we said sine 30 is 1 over 2. So here becomes length is equal to 2 times root 3 times 1 over 2. Aha! If 2 should cancel out 2, what do I have? The length of the chord is root 3 centimeters. Simple. I know most of you will want to go with this. Most of you will say, oh my God, this is cool, this is short, no diagrams, nothing. You will want to go with this. But the fact is this, not every time that you can make use of this formula. I will tell you when you can make use of this formula. You can only make use of the formula when the angle at the center is given, which is theta. If the angle is not given, there is no way you can make use of this formula. So class, this is the answer to question number 1. Like I said, we will be solving 2 questions. And I hope you understood how we got root 3 in the first method and also how we got root 3 in the second method. Don't forget to subscribe. Don't forget to share. Now, let us begin our next question, which is question number 2. All right. Okay, question number 2 says, okay, a chord 7 centimeters long is drawn in a circle with radius 3.7 centimeters. Calculate the distance of the chord from the center of the circle. Now, you see, the reason why I told you it is not in every cases that you can use the second method, which has to do with the formula for length of the chord. Because if you see this question now, there was no angle given, and so there is no way we can make use of that formula. So you have to draw. So now let us present this information out. We were given the length of the chord here in this question. So our length here was given as 7 centimeters. And then we were given the radius also as 3.7 centimeters. And then we now are asked to calculate the distance of the chord from the center of the circle. Okay, so it means here, the options given now are A is equal to 0.7, B is equal to 1.2, C is equal to 2.0, and D is equal to 2.5, all in centimeters. Okay, now how do we solve problems like this? First of all, let us present this information in the circle. Now this is our circle, right? And this is our chord. Now let's assume this is the center of the circle. So it means this is a radius. And this is also a radius. And according to the question, the radius given was 3.7. So here is 3.7 centimeter. Here is also 3.7 centimeter. And then no angle. There was no angle given in this question. So let's say here is A, O, B. Now, we also was given the length of the chord to be 7 centimeter. The whole length. But now, what are we told to calculate? You see, sometimes you are not told to calculate for the length. You are told to calculate for something else. Now, what did they tell us to find? We were told to calculate this line now, which is the distance between the center and the chord, which is the bisector. Don't forget this is angle 90. Don't forget this is also angle 90. Now, how do we solve for this line? Okay, how do we solve for the distance between the center and the chord? Now, let us say, first of all, don't forget line AB is equal to 7 centimeter. Now, if this is point C, which is the bisector line, now this is what we're going to do. It means that AC, BC. To get AC will be equal to 7 divided by 2. Because if the total line is 7 centimeter, so to get each point here, okay, we are going to divide 7 by 2, and automatically that gives us 3.5. So it means AC is 3.5, BC is 3.5. Now, I will tell you the reason why I did that. Now, this is what we're going to do. Using AOC alone to solve. Let's bring it out. Okay, and this is angle 90. This is our A, this is our O, and this is our C. Meaning we are using this side of the triangle. This is what we're going to do. AO, according to the question, 3.7. Now, AC, now remember we solved for AC. AC now is 3.5. But we don't know OC, which is what we are told to find. So let us say here is X. Alright, it's as simple as this. Now, without wasting time, there is no way we can apply basic trigonometry ratios which are so catois. Why? Because no angles was given. Okay, so now what are we going to apply? We will be applying Pythagoras theorem. Now, when do you apply Pythagoras theorem? Pythagoras theorem is applied on a right angle triangle. Now, we all know this is a right angle triangle because of the angle 90 present here. Now, not just on a right angle triangle alone, but when two sides of a right angle triangle is given, and then you are told to find the third side of it. So now, here was given, we are told to find the third side. And according to Pythagoras, when you only add when you are looking for the what? The hypotenuse. But of course, the hypotenuse was given as 3.7. So what do? We are going to subtract. So now, here becomes x squared. X squared is equal to 3.7 squared minus 3.5 squared. Okay, now let's proceed. Square becomes 13.69 minus 12.25 gives us 1.44. Now, of course, for us to make x the subject of the formula, square has to cross the right hand side of the equation and become square root. So here becomes x is equal to the square root of 1.44. And of course, the square root of 1.44 is 1.2 centimeter. Now, if you come to the options, you see that 1.2 centimeter is B. So this is how you can solve problems under theorem 1 of circle geometry, which has to do with perpendicular chord bisector. So class, with the help of this, we have come to the end of today's class, and I hope you have learned something new. So please keep on working with this formula. Try to solve other problems involving this theorem rather. And then in our next video, we shall be looking at circle geometry theorem 2. Don't forget, if this is your first time joining us, don't forget to subscribe. Don't forget to put on your notification button. And of course, you can follow us on Facebook, Mathematics Booster, and we are also there waiting for you on TikTok, Math Not Hot. Till we meet again in our next class, thank you for watching and bye for now.